Welcome and thank you for joining. We'll continue with the lesson on limits, and this time we'll explore how to use limits to find the instantaneous rate of change of a function, or in other words, the slope of the tangent drawn to a point on the graph of a function. Recall that the tangent line is a straight line that touches the graph at a single point. And the slope of the tangent helped us determine how fast the function is changing at that point. So we visited this concept actually in advanced functions and at the beginning of the course in calculus, and we said that to find the slope of the tangent at a point where x equals a, then we had to find the value of the expression f of a plus h minus f of a divided by h. And once we substituted a plus h instead of x in the function, we simplified this expression, and at the end, we remember to make h equal to 0 in order to evaluate the slope. So, as you can see in here, the formula that we use for the slope of the tangent is a function on its own, and we aimed to simplifying h from the denominator because otherwise the value of the slope, or the value of this function we should say, was indeterminate at h equals 0. So as you can see then, we can compare this process that we use to find the slope of the tangent with the process of finding the limit of a function at a point where the function was indeterminate at that point. So in this case, at h equals 0. So we are going to add a new interpretation of the slope of the tangent, or instantaneous rate of change. They mean the same thing. And we're going to say that we're going to find the slope of the tangent as the value of this formula, this expression that represents the slope of the tangent that hasn't changed, is exactly the same as we've seen them in functions and in the calculus. So f of a plus h minus f of a over h. But we're going to add the notation, the limit, as h approaches 0, because basically that's what we did when we found the slope of the tangent. We made h equals 0, but we didn't put that in this notation, in limit notation. So basically what we are doing here is finding the slope of the tangent the exact same way we learned at the beginning of the unit, but we are going to add the meaning of limits. So we're going to use limits to express that. So let's get started with one example just to show what the structure of our work will be like. So in the first question here, we're asked to find the slope of the tangent to the function f of x equals x squared minus 5x plus 1 when the tangent is drawn at x equals negative 2. So step number 1 would be to write down the formula for the slope of the tangent, which will be equal to the limit as h approaches 0 of, I'm just going to write the formula, f of a plus h minus f of a divided by h. So again, I just want to reinforce this. We're still using the same formula for the slope of the tangent. Where we made h equals 0, we had to remember to make h equals 0 at the end. But here we're reminding ourselves at the beginning by using limits. That's the only difference. So since we're finding the slope of a tangent at some point, which according to the formula is at a, it means that we're finding the slope of the tangent at negative 2. So the value negative 2 here will represent the value of a. So I will rewrite this formula once more, and I will substitute a by negative 2. And obviously the first step can be ignored. So you can, when finding the slope using limits, you can just throw in negative 2 in the formula, right? And that would be over h. So now let's substitute in our function. We have the limit again as h approaches 0. This has to stay here until we evaluate. And look at the equation. So instead of x, now we'll have to substitute negative 2 plus h, which means that we'll have negative 2 plus h squared. So let's write that down. And then minus 5. Instead of x, we'll have to write negative 2 plus h, so minus 5, negative 2 plus h. Wait a second, we're not done yet, so we have plus 1 here. So plus 1. So This part of the expression here in the limit would represent f of negative 2 plus h. So we'll make this a little bigger. Here we go. And now we'll subtract f of negative 2. Let's make this a little longer. So in other words, we'll have negative 2 instead of x. So evaluating the function in negative 2, that's easy. Let's not be dramatic here. So negative 2 squared. I'm writing the steps for the obvious reasons. And then plus 1. And then we have over h. So this part in here is right here. So let's continue simplifying. I'm going to take this one up here. So we have the limit. H approaches 0. Big fraction line because we're expanding now. So here we go. We have to do this very quickly in one step. We're in grade 12 now. So negative 2 squared, that's a 4. And then plus 2 times negative 2 times h, right? You can do this in one step again. So hard for me to do this a bit faster. I'm so worried that I'm going to lose someone, but please review your expansion of special binomials, the expansion of special binomials. So here we go. Negative 5 times negative 2, positive 10. And negative 5 times h, negative 5h, and then plus 1. Now let's take a look at what this part here becomes. I will highlight this, obviously, here. And then minus. So here we go. We have negative 2 squared, that's a 4. Minus 5 minus 10, that's a plus 10. And then plus 1, so 10 plus 4 plus 1, that means 15. So minus 15. Here we go. And that's over h. So we need one more step to simplify. So big fraction line again. So we have 4 plus 10, 15. Minus 15, nothing. So 0. So that means that we can simplify the numbers here. Now next we are going to, I forgot the h squared in here. So we are going to simplify the rest. We have negative 4h, negative 4h, negative 5h. So that will make negative 9h. And then plus h squared over h. Okay, so we don't need that longer line. So here we are. And as we can see now, every term in the numerator will have a factor of h, which will help us simplify the h from the denominator. And that's the way it's supposed to happen, right? So if we end up with a constant here, which means h is not a common factor, that means we've done something wrong and we have to go back and check what we have missed. So the limit as h approaches 0 of h, we have negative 9 plus h in here divided by h. And then we are going to simplify h because we can't wait. And that would be the limit as h approaches 0 of negative 9 plus h. Remember to keep this in brackets because they're both inside the limit. And now it's time to substitute h by 0, and the value would be negative 9. So that would be the slope of the tangent. The slope of the tangent drawn exactly at x equals negative 2. So if you want to check and see if your answer was correct, so what you want to do is draw the graph of the function. You can easily use decimals and check and see what the slope seems to be like at x squared minus 5x plus 1. So let's do this one very quickly here. And just so I can show you how to check your answers in case the answer key is not provided. And x squared, we said minus 5x, I think, plus 1. Okay, so that would be the graph of the function. So at x equals negative 2, so let me go all the way to negative 2. So at negative 2, we're down here, we're all the way up here. There we go. That's negative 2. So this is where we're drawing the tangent at negative 2. Oh, so hard to hold it. So you can tell that the slope of the tangent here would be a negative number, and it kind of is quite steep when you think about it. And it does make sense for it to be equal to -8. So I'm going to bring this one here on the screen so that we can talk a little bit more about this. So this is a graph of the function y equals x squared minus 5x plus 1, and we drew the tangent right at x equals -2. So we drew the tangent somewhere in here, and I'm going to draw a tangent line in here, and you can tell that this is kind of quite steep and negative. So I'm going to extend this a little bit further. As a matter of fact, I just want to actually find the equation. Oops, I cannot do this. So I want to find the equation of the tangent line, because that would be a question commonly asked, as a matter of fact. And to find the equation of the tangent, I always start off from y equals mx plus b. And since I already know the slope, I just found the slope from the limit, -8, then I will have to substitute an x and a y from the graph. And x equals -2 and y equals 15 will be an easy point to use, because we already had to find the value of the function at -2, so that was 15. So that's ready to use, and then plus b. That will help me find the value of b, which is 16 now, plus b. That means b equals -1. So take 16 to the other side, obviously. So let me show the steps again. And b equals -1, which means that the equation in slope y-intercept form would be -8x minus 1. Now, this would be slope y-intercept form, but if we were asked the standard form, which is ax plus by plus c equals 0, remember a, b, and c have to be integers, and a has to be a natural number, right? So, or we should say a must be positive integer. They're all integers, by the way, but a has to be positive. So that means that all the terms must be be brought to the other side, so one side. So I'll bring everything to the left. So -8x will become positive. Y is already on the left side. -1 will become positive. And there we go. We got the equations of the tangent in both slope y-intercept and standard form. So this is how we find the slope of the tangent using limits. And here we have another example that you can try on your own. I'll try to go over video and record the solution, but please try this on your own. It's not difficult at all. And I hope you find this fun, and I hope you found the instructions useful. Bye for now.